So the code that we had so far is we said we're going to make something that is going to be a stack. It's going to do whatever stack interface says or the normal operations. So we've just got push, pop, peek, and size. We said in order to do a stack, we're going to keep all of the items for the stack in an array, and we're going to keep track of next free to fill. Okay. So one of the things that starts to become obvious as you play with this code is you go, oh, well, we've done this before. This is almost exactly what we did for object lists with an array underneath. As a matter of fact, the code is pretty much identical. Okay. So initialize the thing. You can initialize it to any size you want. The only trick that we might play here eventually is allow people to specify a size on the constructor so that they get a fixed length stack of whatever size they want. Most times stacks are unlikely to grow. The assumption in most computer programs is that stacks are of a fixed size when they're allocated and they're never going to change. So we got our array initialized to however many values, and then we wrote push, and push is just take whatever thing they give you and dump it into the next available position, and then bump up next available position. Pop, the reverse, is figure out what the last one is, remember the last one, say we've got one less, clean it up, and then return the last one. Which leaves us with peak and size. So what's peak going to do?
It's going to return the most recently added one.
Which is the last filled slot. So if we just take this stuff here and don't actually change anything, then we get that code. Okay, so you can shorten it if you want, but I just kept exactly the same idea of figuring out what the last filled slot was. And size is going to be next free to fill. So that variable is playing two purposes, both the next empty slot and the size, because they're essentially one off. Okay. And there's the entire code for stack. Okay. And I've still got my little git problem that I haven't fixed, so it's going to complain about that constantly. Okay, so there's our array version. We have some tests to see whether or not it works. I just added a test to push and pop a bunch. It's not actually 3 anymore. So I basically added another test that says let's put 3 things on, take 1 thing off, add another one back on, and then take them all off again. That's all that thing does, just so that we've got something that does more than 2 things with the stack. Okay. And we run it, and it all passes. Done. Okay. So there's our working stack code. And again, it's not like that the stack code is difficult, but the nice thing now is that anytime you write code and you use the word stack in your code, you've got something that manages the stack for you, and other people know exactly what kind of problem you're trying to solve. Okay? Well, that was the easy one. Let's do the same thing again. Instead of using an array underneath, let's try using a linked list underneath instead. Okay, so more practice with linked lists. So what I'm going to do is I'm going to make a new Java class called stack linked, and it's going to hold on to E-type things, and it's going to implement stack interface for E-type things. And then we'll get Eclipse to fill in, did I call it the correct thing here? Double check. Spell it correctly, or put it in the wrong file, one of the two. That's probably more likely. Just save this for a moment. I just stuffed that into the wrong file. take that one, slide it back up into here, and do stack length there. Okay. So we'll add the methods that we have to write, and now we have to talk about how we make a stack with linked list. So let's start out, let's draw a diagram, and let's draw a diagram that supposes that here's the driver program. The driver program needs to hold at least a couple of variables. We'll say one is the size of the number of items, and then the other thing is the chain of all of the items that we happen to be keeping on the stack. Okay, so I keep saying that all of these diagrams essentially look alike. Anything with a chain of things, there's the sort of the diagram that you end up starting with. Okay, so got three things on this chain. Suppose I want to push another one. How are you going to push another one onto the stack?
You have to insert it ahead of the others.
Well, you got two choices. If your stack is, let's do this right, A, B, C. Did I do that right? Let's do this right. If we push A, B, and C onto the stack, conceivably you would start out with A, and then you would tack B on, and then you would tack C on to the end. Okay? This is how we did the thing originally. Any problem with that? You always have to run through the links, right? So if we want to push D on, then we have to run through the chain and push D on. And if we want to remove D, the last one we put on, then we have to run through the chain and find C in order to remove D. So if we do what we did for using this thing for a list, the problem that we have is that we're always doing worst case every time through this chain of things. Okay? Where's a more convenient place to put things? Right at the front. Because if you put them at the front, to remove something, all that you have to do is say, there's the one, link around it, right? And if you want to insert a new one, oh, you just make a new one, you chain the new one to the one that's already there, and the head of the list to that one. Okay? So in this case, it turns out that it's more convenient and more efficient to always insert things at the front of the chain rather than going to the back of the chain. Right? And as soon as you recognize that, the code actually becomes really, really easy to write. Okay? So let's go in and say that the first thing that we're going to need is the node class, and I can borrow the node class from chained list, because it's essentially the same. It's up there somewhere or down there. Okay. So let's just steal that node class for our code. Wondering what that error is. Yeah. Get rid of the silly import statement that Eclipse puts in for you that you don't need. Okay, so there's our node class. So what we'll do here is we'll make a private node start of chain variable again, and we might as well keep track of the size of things just so that we don't have to remember it or go searching for it all the time. So if we make a constructor, start of chain starts out as empty, and item count starts out at 0. Okay. So suppose somebody says push. How do you put something onto the chain? And again, the trick here, quite often when you're writing this code, is to think of an intermediate result. So let's suppose here that there's our chain already, and we pushed A, B, and C onto the stack, and somebody comes along and says, I want to push D onto the stack. What do you do to get D onto the stack?
Create a new node.
So first thing is we'll create a new node. So that would be a new node that takes the thing in. So that will give us a variable called new node. Sure. So there's that done, and we've made this thing point to conceivably D up there. Now what? Start of chain refers to C, and we want the D to refer to C. So new nodes next needs to have the same value as start of chain. Okay. So take start of chain and dump it into new node dot next, which draws this line to there. Now what?
Start of chain has to point to new node.
Start of chain, instead of referring to C, now needs to refer to D's node. D's node is called new node, so if we take the value from new node and move it into start of chain, that will draw that line. So we'll take the value that's in new node and we'll move it into start of chain.
Need a capital O.
Okay, so that draws this line to there and breaks that line. And now if you look at the chain, you've got start of chain pointing to D, D's node points to C's node, and your work is done. Okay, this variable is going to disappear. The new node's variable is going to disappear. Anything else we should do?
Item count.
Item count needs to go up. If start of chain changed, then item count needs to go up. Okay. Notice how I wrote the code. I basically said, what do I need to do on the diagram? I had the diagram help me write the code, and then came over here and wrote it. And that's the easiest way to write all of this code. Almost every piece of code that you write there draws a line between something. It's sort of one for one. And so you can go and write the code from the diagram. Conversely, if you see that code and you want to figure out what it does, it's easiest to draw a diagram midway through and then go follow the code and see whether or not it gives you the correct picture. Okay? And that's the big help. And it's a lot easier to do that than to sort of stare at the code and wonder whether or not it's going to produce the correct result. Okay? So let's try the same thing for pop. Let's make my diagram less messy again. So there's our chain, and somebody says, I want to pop something.
So you need to get C's next value.
What's the thing that you're trying to retrieve? The important thing.
You need the location of B, C.
That's the thing that you want. What's the name of that thing? Start of chain dot item, whatever it happens to be, is that thing. So what we'll do is we'll play the game of remembering it first. Okay, so there's, remember the one that's interesting. Eventually we're going to send that thing back. And now we can figure out what we have to do in between. So we've remembered that thing. Now, how do you get rid of it?
You need to connect the start of chain to B.
So this value here refers to B. That's start of chains next. So we'll take the value that's in start of chains next, and where do you want to put it?
Into start of chain.
Back into start of chain. Or that's our code for, hey, if you just advance start of chain by 1 and make it stand underneath this one instead, then it's gone. And so we'll just write the standard code here, start of chain equals start of chain dot next, which is advanced by 1, and that says skip over the first one. Okay. And then item count needs to go down because there's now one less, and that's all there is to the code for pop. Okay. What about peak? Peak is sort of start of chain without moving anything, so if we do the same code that we had for start of chain, but we don't bother deleting anything, you get that. Size is item count. And there you go. So again, it's pretty trivial to write code that hopefully keeps things on a chain instead of an array. How about testing it? We basically already have a test, which happens to be called stack array test, but guess what? The only thing that we have to do to make it work is, because these things talk in the same way, is change that to stack linked. Okay. So it would have probably been easier to have done it all in one place, but oh well. Let's just go through and find a few of these. And that's all of them. And so now I've got something that's actually a test for linked list code instead. We can run it, and there's the linked list code. Okay. So there's that idea that also that an interface just represents the standard, and now we've got two different ways of storing things underneath that behave differently inside, but you talk to them in exactly the same way. So you don't notice the difference, other than that there's a performance difference between the two. Okay. Some of the operations are faster than others. Okay. So there's option number 2 for doing a stack. Okay? But notice in both of these cases, we're doing all of the dirty work of having to either manipulate arrays or manipulate linked lists of things, both of which are really, really annoying. Wouldn't it be nice if there was an easier way rather than doing that? So the easy way is to make use of code that we already have. Okay? And code that we already have is something like object list or linked or chained list. because those things already keep a list of things for us. Okay? And I'm going to do it just for fun. I'm going to move over to ArrayList just so that I don't have to import a bunch of code here. So let's do another one, a stack implementation with ArrayList underneath it. All right. So this is going to still take E-type things, and I still want to say implements stack interface for E-type things. Get it to write the methods for me. Did I move this in the wrong place again? Yes, I did. Slide it down into the stack code. Sure. Get it to write the methods for me. There's all of the things that we need to write. And this time, let's call it all items for want of something better at the moment. There's our all items. Do the import statement for ArrayList. So here's stack with an ArrayList, and all that we're going to do is say all items is new ArrayList of E-type things. Suppose that somebody says, push, where are you going to store the thing?
In the array list.
ArrayList, which is all items dot add the thing. Do we need to keep track of the size?
No.
ArrayList is doing it for you, so just let ArrayList keep track of the size. Oh, well, that's easy then. If we go down to the size, we can just return all items dot size. Okay. There's push. What if somebody says pop? What's the interesting one?
One in the end.
The one at the end. Oops. The end item's position is all items dot size minus 1. So we can do all items dot get end item position. That didn't work. And we can store that into an item. Then we can eventually send back the item. And how do you get rid of it? Oops. And send back the item. Efficient or not efficient? Really, well, it's really efficient in terms of removal. There's nothing that's shuffling because we're always playing with the endmost one. We're always adding or removing from the endmost one. So it's about as efficient as you can get. Okay. Peak, we'll do the same thing as we did for pop, except we won't disturb anything. So we won't remove it. We'll just look at it. And there's all the code for stack. Okay. I'm not going to bother with the unit tests. Which one do you think is easier to write of all of those?
That one.
This one, it's trivial because it's, like I said, the interesting thing about stack is it's a restriction on a list. You're saying you're only allowed to look at this one on the list, nothing else. Suppose that I wanted to write an iterator for the chain list version. What's your confidence that you'd get the iterator code correct for a chain list? Meh, a lot of work. How would we get an iterator to work for this thing? We already have one. ArrayList iterator will already go through the items. It actually goes through them from oldest to newest, which might not be the direction that you want, but hey, close enough. All right. You could change it to do it in the other way. Suppose that I'd come up to this class and I'd said, rather than using ArrayList there, I feel like using the linked list class, which is the chained version of the storage facility that Java has. Would it be efficient or inefficient then?
We can be efficient.
Think carefully about this one. If I change that to our version of chained list, which is the same thing as linked list, you're always going, every time you put one onto this list, you were specifically going to the end, which is efficient for things that have an array underneath, but inefficient for things that have a linked list underneath, or at least a singly linked list. So this code isn't just this change here. If you change that to linked list, it actually makes things inefficient. How would you, if you change this to linked list, make pop efficient or push efficient? Always add to the beginning of the list. So if we used linked list here, the good thing to do would be to always add to the 0 position and always remove from the 0 position, which would actually be easier to write because you don't even have to calculate where it is. It's just always the 0 position. Okay? So if you change this code to use linked list, it becomes smaller, it becomes easier to write, you get iterator for free. The iterator would end up going from the newest to the oldest, which is probably what you want, and life would be really, really good, and it would be easy to write the code. Okay? So in the old days, people would have said, no, I'm going to write this code myself. I'm going to write it with an array or a linked list. It's trivial. I can get it to work. Ha, ha, ha. Won't take very long. Oh, yeah, you want to throw in an iterator? Yeah, off we go. Yeah, I can do that. And you spend a lot of time doing it, and you don't know whether or not you really have code that works. Or you can do it the new way, which is to say, well, let me just add another layer, use some facility that I already have. Yeah, it's probably not as efficient for Mr. Computer to do, but it's trivial for me to write and make sure that it's correct. Okay? And so the layered approach in this case probably actually works better. One more question out of interest's sake. What happens... to think about this carefully. Why didn't I just extend ArrayList, which is the other way that we could have done this? Okay? The other technique to doing this would be to have stack ArrayList extend ArrayList, which would mean then I would inherit all of ArrayList's methods and I wouldn't have to write any. But what would be the downside?
You might have code that...
You wouldn't be able to restrict what people might be able to access.
Yeah, you can't restrict people anymore because all of a sudden, if you just layer on these extra push and pop methods, people can still come in and remove things from the middle of your stack or add things or insert things or do whatever they want, and so you're not actually doing the restriction. You could fix that by extending ArrayList and then taking all of the methods that you didn't want people to use and writing your own method that did an override and either did nothing or threw an exception. But trying to get at all of those methods that ArrayList has and fix them all tends to be too much of a problem. So extends is all right if you're really in truth adding two or maybe wiping out a couple of them, but if extends ends up being more of a problem, then it's easier to bury the array list inside a class and just only restrict it to doing the things that you want to do. Okay? So in this case, that worked better. Okay, so now we've got three different ways of making a stack, or four if you include linked list underneath, all of which work perfectly fine. It turns out that there's already a stack class in Java, just like there's a linked list and array list class. So we're really, in the long run, not going to have to write them. But let's use these ones to try to do a couple of sample problems. Okay, so now that we've got the infrastructure in place, let's see if we can do some sample ideas. And while we're at it, let's just go look at the stack class in Java, because maybe what we'll do is we'll use it for a change. So here's the existing stack class. And the stack class has been around for a long time. There's a fancier version of the stack class that we won't worry about. Stack just has an empty constructor, and there's all of the methods. There's empty, peek, pop, push, and you can do a search to see whether or not you can find out if something's on the stack. How do you think it does search? What's the requirement if you're searching for something? Equals is going to be necessary in order for that thing to work. So if we come down and look at search, we should see the word equals there to say, yes, that's the way that it's going to do the matching. Do we get an iterator? Turns out that a bunch of the methods are inherited from a previous class. This is an old one that's been around. This is the old version of ArrayList that Stack happens to use, but it looks like it does sort of maintain everything, but it's also got an iterator. Okay? So notice what they do with this stack class. They say we're actually going to extend an existing class, and if you really, really wanted to, you could use all of these things, but we'd prefer that you just stick with those, and that'll give you the stack. So they don't even wipe out the other ones, so it looks like you could actually sort of kind of destroy the stack if you wanted. So let's try to use that one, and let's think of a couple of examples here. So the first example I'm going to do is the easy one, and that's the example we have in the web browser. And let's just see whether or not we can get at least the basic methods here. Okay. So we said that if we looked at a web browser, the back button had a stack underneath, and the forward button, which is currently not highlighted for me, had a stack underneath it. So let's write a class for the web browser that keeps track of the two stacks and the current URL for a web browser, so that all the browser has to do is go, oh, somebody typed something here, keep track of it on the stack. Somebody hit the back button, go tell me what the latest thing is. Okay? So let's just see if we can get a class started here. We'll call it web history. We've said that the two things that we have is a private stack for things that are under the forward button and a private stack for things that are under the back button. And we'll do use the Java version of the stack class, we'll write a constructor. And we'll set the forward to a new stack, and we'll set the back to a new stack. What types of things do you think that should be stored? What would you call this thing?
Web address.
Well, yeah, it's a string, but it's a specific kind of string. So yeah, web address or URL. Okay, so if you call it a string, which we could do, you know, you could say it's a stack of only string. The problem with using string there is that you might want to do things with that string, like validate it to make sure it's an actual URL, etc. You might want to be able to tack things on or complete addresses or do a whole bunch of things with URLs. So the trick here is to not make it a string. The trick is to say, well, let's just make you called it a web address class. It might actually be URL, but sure, we'll use web address. I think Java actually already has a URL class, but that's okay. So what we'd do is we'd make a web address class, and we'd say private string, you know, URL or something like that. So we're just going to bury the string someplace like this. Probably not the best capitalization, but that's okay. Okay, and we'll do a public string get URL that returns the URL for a start. Okay, so the whole reason for doing this is not that currently it's anything but a string, but that eventually we might want to do things like add validate methods or things to actually check and see whether or not that thing constitutes a valid URL. So that's just done for the future, so that now what we'll do in here is we'll store a web address instead. So that's going to hold web addresses. That's going to hold web addresses. When we make a new stack, it's going to hold web addresses that way. Okay. One more quick thing. Should we keep track of the current URL?
Yes.
There's two choices here when you make this thing. One is to say that's a separate thing. The other thing to do would be to say that that's always the top of the thing at the back button, right? In which case it would just always be a peek command. But sure, we'll do it this way. Private web address, current URL, and current URL starts out as nothing, as a new web address with nothing. Okay? The joy of putting nothing in there as a string, that if you were to display it, it would show up properly as nothing. Okay? So there's the start. So what we'll do on Monday is we'll finish this off really, really quickly by saying, okay, what happens if somebody hits the forward button? Here's the information that's provided. What happens if they type something new? And we'll just write a quick thing to manage the movement of the things back, the information back and forth between those three variables. The exciting stuff happens after we do this one, because the next example I'm going to use is one where we get to run through a forest hunting for beer. So
Do
for
you
the
often
next,
find beer in the forums?
for the next 2 or 3 or 4 lectures, we're going to be really interested in beer.